When I say norms, I mean these things. We looked at these cards the other day and we said we are going to follow these norms, these expectations in every activity that we do this year when we work in groups. I want you to try to recall them. If you can't remember what the list was from this, then think about this. Think about what you need to remember to do when working in a group. Carrington? Participating? Oh, I like that one. Meaning everybody in the group does something, speaks, shares. Yes. Stay on task. I love the way Carrington got one right off of this, and Jose got one right off of this. Staying on task is huge. Sixth graders like to kind of talk about other things sometimes. Yes. Listen to the other person that is talking. So much so that you could paraphrase. Remember, that was on here. Is that what you were going to say? Paraphrase what they said. We're going to be doing a lot of group work today, and in our group work, I really need for you guys to put these norms into practice. Pausing, paraphrasing, posing questions, putting ideas on the table, providing data. That's going to be a big one today, providing data. Paying attention to yourself and others, presuming positive intentions, meaning assuming someone that isn't trying to be mean or malicious in the group or out to get you or whatever in the group. All of these are extremely important, and I want to put these into practice today. One that I really want to work on, other than providing data today, is pausing. Today it's going to be very important to not only pause after somebody said something so you can just kind of take it in, but also to pause as you are reading through something super, super interesting and important later in class. Okay? So we're going to keep these out. Just to remind us of what I expect of you when working with a group. Any idea what this is a picture of on the smartboard? Raymond?
The moon.
Okay, the moon. Any other thoughts? Yes? Venus? Excellent guess. Yes?
Mars.
You think it's Mars? Any other guesses? Yes.
Jupiter.
Good guess. Jupiter. Any other guesses?
Mercury.
Mercury?
Atmosphere.
Oh, atmosphere. Good word there. Yes.
Pluto.
Pluto? Any other thoughts? David is actually correct, you guys. This is a picture of Mars, and Eve is also correct. This is a picture of Mars's atmosphere. What do you notice? I showed you a picture the other day of Earth's atmosphere. What do you notice right off? What's different? What do you notice right off? Yes?
It's a different color.
Oh, it's a different color. That's an excellent qualitative observation. Miss Lockett. Craters. Yes, on the surface. Very good. Yes?
This one looks more darker and the other one looks more lighter.
Darker, lighter. Yes.
It may have 21 craters.
It may have 21 craters. I like that quantitative guess. Yes?
It looks pretty sandy.
It looks pretty sandy. So you're saying the surface looks different, right? Okay. Well, I want to show you guys a couple more pictures. As David said, this is Mars. And as Eve said, this is Mars's atmosphere. I want to show you some other pictures. Some of you may have seen this before. This is the rover that we have sent up to Mars. What is the rover doing, do you think? What do you think the rover's doing up on Mars, just out of curiosity? Yes? Looking for life? Okay. What do you think? Gathering information, gathering data. Yes?
Seeing what's different on Mars than Earth.
Seeing what's different from Mars than Earth. Yes?
Gathering rocks to see if anyone's been there.
Oh, so literally picking up pieces and bringing them back to Earth. Okay. Yes?
Atmospheric coordination.
Atmospheric coordinations. What do you mean by that?
The data.
Like the data, like what the atmosphere is made of? Well, you're kind of on the right track of what we're going to be doing today. I thought it would be interesting, since we've been studying the atmosphere, right? Okay, we're familiar with the layers of our atmosphere, and we're familiar with what makes up our atmosphere, are we not? Remember this activity? We're familiar with what makes up our atmosphere. I thought, how cool would it be to compare our atmosphere to Mars's atmosphere? Comparing seems to be the verb of the day, doesn't it? Just like we compared the layers, we're going to compare our atmosphere to Mars's. Somebody remind me, just to refresh. We did this activity. What was our biggest gas? What was our most abundant gas in our atmosphere? Yes, ma'am.
Nitrogen.
Nitrogen, at what percent? Do you remember? 78%. Very good. Okay, followed by what gas, Angie? Oxygen, at what percent? 21%. And then we actually played Recall What You Saw. Remember that game to try to remember those trace gases that are in the atmosphere? Carbon dioxide, right? Roughly, this is what our atmosphere looks like. So what about Mars? How would it compare? Do you think Mars has as much nitrogen as we do? We have a huge amount of nitrogen, don't we? Almost this whole pie is nitrogen. Okay? But what about Mars? What does their atmosphere look like? Any guesses before we gather some data? 21% of what?
Nitrogen and 0% oxygen.
Oh, and 0% oxygen. Why do you say that, Des?
Because no one can be breathed in space.
Oh, okay. So you're relating it to space and what you know about space. Excellent. Any other guesses? Yeah.
It may have no other gases and 0% oxygen, and the full pie is nitrogen.
Okay. Any other guesses? Yeah?
Maybe it has a lot of carbon dioxide.
A lot of carbon dioxide. Why do you say that?
Because not that really much oxygen.
Not that much oxygen. Interesting. Yeah. In Miss Schaeffer's dream world, we would hop on a space shuttle and go to Mars ourselves and find out all this information that we need to know. All right? Because we want to investigate Mars's atmosphere today, and I would love to be able to go there or somehow have communication with the rover or something. But unfortunately, we don't. So we are going to look at an article, gather some evidence about Mars's atmosphere. We are comparing Mars's atmosphere with ours. I have passed out to you an article actually not about our atmosphere, it's about Mars's, because I feel like we already have a good solid background sort of on our atmosphere. All right? We need to find out more about Mars. So here's what we're going to do. I need you guys to pull out of your bucket to have a highlighter. It does not matter what color. I need everybody to have a blue. It does not matter what shade of blue. And I need everyone to have a red. And the red can be kind of an orange. That's fine. We're kind of going to do a fancy highlighting activity called decoding. I'm going to give you guys a key, and I want you with your pencil to write the key at the top of your page in regular pencil. Write your key, what you're going to follow, as you decode and highlight this article. Okay, so here's what we're going to do. If something you read is a similarity with Earth's atmosphere. So if something is similar, I want you to underline it in blue. If it is something different, I want you to underline in red. And if it's just something interesting that you think is worth sharing with the class, I want you to highlight. I don't have a yellow expo, so if it is just an interesting fact worth sharing, I want you to highlight it in whatever color you have, whether it's pink, blue. Somebody tell me, if it's a similarity, what are you going to do? Tess? Underline it in red. And what do I mean similarity? Similarity to what? The Earth's atmosphere. Very good. So if it happens to say like that Mars just happens to have 78% nitrogen, is that a similarity? Yes. All right.
Do we just underline the whole thing? Or just the definition?
What do you think? If you think it's a similarity,
I just read this.
make that choice.
Oh, and this one we can write as a difference that says too thin to easily support life, as we know it that it doesn't have like that much life. That's a difference because we do have one. Oh man, underline in red. Because it says too thin to easily support life.
And it is 95% carbon dioxide. 95% carbon dioxide. So it will be different. Here's a breakdown of its composition. Carbon dioxide 95.32%. Nitrate is 2.7%. It's different than ours. Ours has 75%. Argon is 1.6%. It's different too. And oxygen 0.13%, and ours is 21.
So what color pencil do you use if it's different?
Red,
Okay. And what color do you use if it's the same?
blue.
Okay. So be careful, okay?
Oh, I messed up.
That's okay. I don't want you to go back and look at your key and be confused based on what you read and what you colored.
I love how this room is decoding and on their own, but I don't hear much discussion. Okay, part of this is for discussion.
I try and ask him if he wants to read to me or I want to read to him, but he won't answer.
Okay, well, then maybe we'll just have to make the decision for it. All right? So, are you guys telling me that at this point all these are differences or similarities?
Differences.
Differences. Excellent. Okay, so just tell me, for example, why did you highlight oxygen 0.13% as a difference from Earth?
Because it says up there its other gas is 1%, and this it says 0.13%.
Let me ask that again. It's 0.13% here. How much does Earth have of oxygen?
21.
21. Is that a huge difference?
Yep.
Oh my goodness, yes. Okay. I want you guys to you'll have to make the decision then to read for him. Okay, she's going to start at the bottom because he doesn't have a lot highlighted, and I want you guys to continue sharing similarities and differences. Okay, you start reading. Mars is much colder.
Mars is much colder than Earth, in a large part due to its greater different distance from the sun.
Okay, hold on 1 second. Let's pause. Kind of have to read and pause. So, Mars is much colder than Earth. You highlighted that as an interesting fact, but isn't that a difference too?
Yeah.
So let's underline that in blue, like Wendell did. Excellent job. Or,
I
I mean,
thought
the
you
difference is red.
but it
Sorry.
says-
I'm sorry. I misspoke. Difference is red. And it says, in large part due to its greater distance from the sun. So it's further from the sun. I would underline that in red. Underline in red. That's a difference. The average temperature is about minus 80 degrees. That is good. I love the way you guys underline that in red. Keep reading. I'm sorry.
minus 60 degrees Celsius. Also, it can vary from minus. Although it can vary from minus 195 degrees Fahrenheit, minus 125 degrees Celsius near the poles during the winter.
That sounds like a difference, don't you think? I think all that's different from Earth.
It's nice and comfortable.
Okay?
70
I want you to
degrees.
practice stopping and pausing. Okay? Stopping and pausing. In fact, next vlog I'm going to put out those cards to remind the kids about the norms. So can you keep reading and then pause?
It's comfortable 7 degrees Fahrenheit.
I can't hear you.
It's 7 degrees Fahrenheit, 20 degrees Celsius at midday near the equator. What do you think that is? Window.
She's on the back. What do you think that is? At the top, is that a similarity to Earth or different? Different. Very good. Okay?
More and wind and kicking out more dust.
Giant dust devils.
We have done dust. We have dust devils.
Yeah, we have dust devils underlined in blue. we have dust devils, giant dust devils. We recently kicked up the awkward iron dust of covers of Mars surface. That's an interesting fact.
What? Kick out the oxidized iron dust from the covers of Mars.
Right.
From there?
Yeah.
From there to here?
Yeah. The dust storms of Mars are the largest of the solar system.
Dioxide, 95 through 35, 95.35 present. Nitrogen, 2.7 present. Argon, 1.6 present. Oxygen, 0.
What?
Mars has been highlighted the underline.
Alright, does Earth have them?
I don't think so.
Different. It's different. Alright, let's read Earth real quick. Dude.
The oxygen difference is different. It's 21%.
Let's read Earth real quick.
Read a chunk and stop and decode.
She said read a chunk.
I'm gonna read that right there. Too thin, too easy. Support life as we know it. The extremely thin airs on Mars can also become very dusty. Ours isn't thin, but ours becomes dusty in certain areas.
What?
Mars is
Ours
much
is
colder
the
than
atmosphere
Earth
right there.
in regular parts
See
due to
that
its
line
greater distance
and all
from the
that?
Ours is like up here.
What, our atmosphere?
Temperature is about. We have a lot more layers. Theirs is thin.
There it says that it's less than 1% of carbon dioxide. So that's the difference, right? The nitrogen, ours is way bigger, 70 something. And right here is only 2%. That's different. The argon is less than 1% because that's like the carbon dioxide.
Yeah.
The oxygen is 21% here, with this 0.13.
It says researchers suggest that liquid water may be present underground, providing a potential refuge.
Wait, where is?
Here's what needs to happen.